Hey, coding enthusiast! I welcome you to an exciting journey ahead as we delve into the powerful world of Spark programming. Spark has revolutionized big data processing, enabling us to analyze massive datasets with lightning fast speed. Whether you are a data scientist, a software engineer, or simply a curious learner, mastering Spark can open up a world of possibilities for you. In this course, I am going to take you through the fundamentals of Spark programming, from understanding the basics to writing your first Spark application. We will cover all the essential concepts, tools, and techniques that will empower you to unleash the true potential of Spark. In this course, we will have a total of 7 sections that are designed to help the students learn progressively. We will start with the basic introduction and installation of Apache Spark on local system as well as in cloud. Moreover, we will learn how to configure Spark in PyCharm IDE and gradually move towards intermediate concepts of Spark. After that, we will learn about the Spark programming model involving data frames, setting up Spark build configuration, configuring a Spark session, and handling application logs. Then we will move towards data sources and sinks, in which we will learn about Spark APIs and how to create data frame schema. Finally, we will cover transformation of rows and columns, and we will learn about aggregations and joins in Spark. And in this video, we are going to talk about Apache Spark. Apache Spark is a unified analytics engine for large-scale data processing. Apache Spark is a distributed data processing framework, and this diagram represents the Spark ecosystem. This diagram is going to help us understand how the Spark ecosystem is stitched together. So, the Spark ecosystem has two layers. The bottom layer is the Spark core layer, and the upper layer we have a set of libraries and APIs. These two things together make the Spark ecosystem. The Spark core layer further has two parts, a distributed computing engine and a set of core APIs, and this whole thing runs on a cluster of computers to offer you distributed data processing. However, Spark does not manage the cluster, it only gives you a data processing framework, so you need a cluster manager. Spark was initially based on Hadoop and it was later adopted in Hadoop platform. So the Hadoop Yarn Resource Manager is the most commonly used cluster manager for Spark. However, you have other options too, such as Mesos. Newer version of Spark are also compatible with Kubernetes, which is a container. Similarly, Spark does not come with a storage system, and it allows you to process data which is stored in a variety of storage systems. Some of the most commonly used storage systems are Amazon S3, Azure Blob, Google Cloud Storage, etc. So one thing is clear, that Apache Spark does not support cluster management and storage management. All you can do with Spark is to run your data processing workload, and that part is managed by Spark Compute Engine. Spark Compute Engine is the code that runs and processes your data processing work and provides you seamless experience. So, the compute engine is responsible to perform large number of tasks, such as breaking your data processing work into smaller tasks, scheduling those tasks on cluster for parallel execution, provided appropriate data resources to the tasks, managing and monitoring those tasks, and providing fault tolerance when a job fails. Let's move to an upper level called Spark Core. The core APIs are present in this level. This layer is the programming interface layer that offers you the core APIs in four major languages. And these languages are Scala, Java, Python, and R programming language. These are the APIs that were used to write data processing logic during the initial days of Apache Spark. Now let's talk about the topmost layer, which is the prime area of interest for most of the Spark developers. This layer consists of a set of libraries, packages, APIs, etc. When you use any of these libraries or APIs, you will actually be using the underlying Spark core, and ultimately things will go to the Spark Compute Engine. This layer is divided into four categories to support four different types of data processing requirements. But things are going to overlap in most of the real life projects. The first group is a collection of two things, Spark SQL and the DataFrame APIs. The next one is the Spark streaming libraries, and they allow you to process unbounded and continuous streams of data. The next one contains libraries to specifically meet the machine learning, deep learning, and AI requirements. Last category is of graph processing libraries. They allow you to perform graph processing algorithms using Apache Spark. So the topmost layer is simply a set of libraries to solve data crunching problems, and all these are available in multiple languages. Apache Spark is the most widely used data processing framework, but the main reasons for using Spark are: the Spark will abstract away the fact that you are coding to execute your program on a cluster of computers. In the best case scenario, you will be working with tables and using SQL queries, whereas in the worst case scenario, you will be working with RDDs or data frames. So, all the complexities will be abstracted away. Nextly, Spark provides the capabilities of SQL queries, batch processing, stream processing, structured and semi-structured data handling, graph processing, machine learning, etc. on a single framework. So it provides a multi-platform abilities. Finally, the Spark code is much more shorter, simpler, easy to read and understand. These three things make Spark super powerful distributed processing platform for data processing, and that is why it is most widely used. In this video, you will learn how to configure PyCharm as your Spark development IDE. And for that, firstly, we are going to create a new project in PyCharm. Then we are going to set the interpreter for Python. Then we are going to add the Spark dependency since we are going to use Spark. And then finally, we are going to execute our project. In this series, I am going to use the PyCharm Community Edition, and I am assuming that you already have PyCharm installed on your machine. We will be using Python as a Spark programming language, and if you have PyCharm and Python installed on your machine, then you are all set to use it. So, firstly, I am going to open the PyCharm, and here I have created an empty project. So, the first thing that I need to do is to set up the interpreter, and to do so, you have to go to File, and from there you have to select the settings, and once the settings box is opened, you have to navigate to your project name, and once you click on it, you have to go to Python interpreter. You have to make sure that your Python interpreter has the same version as the version of your Python installed on your system. You can verify it by opening command prompt and typing the command Python in it. It is going to return you the Python version that is installed in your system. So make sure that this version is similar to the Python version that is installed in your system. Close it. Okay, so the next step is to install certain dependencies, and for that open the terminal and type the command pip install, and after that you have to write pypandoc. So this is going to install the directory that is used by PySpark for this project. Once you write the command, simply press enter and the library will be installed. The next thing that we need to install is the PySpark, because we are going to use PySpark with the PyCharm. So for that you have to write the command pip, and then you have to write minus minus no cache directory install, and then type PySpark. So once you press enter, the installation will start, and it is going to take some time for downloading, because it is going to download the data and then it is going to install it into our system. Okay, so you can see that PySpark has been successfully installed into our project. You can also verify it by going to the settings, and inside your Python interpreter, once it loads, you will see two new dependencies added, which is the PySpark and the Py4j. These two are simultaneously installed into your system. Okay, so this shows that they have been added. So the first step is completed. Let's move towards the second step, and for that right click on your project directory and click on directory. I am going to call it data. This is the folder inside which I am going to place my data set for this project. So I have already downloaded this file called sample.csv. It will be present in the Git repository and you can get it from there. Copy it and paste it inside the directory that we just created. So you will see that the sample.csv file will be copied into our data directory of the project. So once it is done, the dataset has been added to our project. Nextly, we will go to our virtual environment, and inside the virtual environment you have to find a directory named lib, and once you open it, you find the lib directory and you will see that it has a single file called init.py. We have to add two new files into this, so I'm going to add two new files called utils.py and logger.py, and I'm going to paste these two files inside the lib directory. So now the lib directory has three files. Okay, so you'll get these files from the GitHub as well. So once the files are placed in the lib directory, I am going to copy some code into my main.py file. So I have already copied some data into here. I'm simply going to select all of this, copy it and paste it inside my main.py file. So this is the code. Inside this code, firstly I am going to change the project name. So this is the code inside which I am firstly importing certain libraries. Then I am going to define that my logger is the log4j. Then I am going to display that if the number of arguments are invalid, it is going to display us the error. Otherwise, it is going to display starting the hello Spark. And then we are going to create a data frame object to read the data from the file that we added inside our data directory. So in this chunk of code, we are creating different data frame objects. Firstly, we are loading the data from the file just that we placed in our data directory. Then after loading the data, we are repartitioning it on the basis of certain value, and then we are simply creating a new data frame object, and inside which we are using the count by country function to count the data present inside the partition data frame. And then simply we are going to display the count data frame, and it is going to return us the count of countries present inside the data frame. Then the logger is going to display us that it has finished the hello Spark file and the Spark will stop. Now let's go and execute the file. Once you click on the run button, you will get an error. This is because we have not set certain configurations. So open your file explorer and you have to go to the directory where your Spark is present. Click on it, you have to go to conf folder, and once you click on it, you will have to find the file Spark defaults config. Your file will have the .template extension. Right click on it, click on rename and remove the .template file. Then open this file and you have to add this line inside it, which is spark.driver.extra java options, and after that you have to provide these values. You will see that it has a value log4j.properties file. So I have this file in my downloads. I am going to copy this from our downloads directory and I am going to paste it inside my project by right clicking and selecting the paste option. So you will see that the log4j.properties file will be placed inside your project. Once this is done, go back to your file explorer and we have to add another file into our project, and this file is spark.config file. Since we are working with Spark, we have to add a different configuration file for it. You will find this file in your Git repository. Copy this and paste it inside your project and you will get the spark.config file in your project. Once this is done, execute your project once again, and once you click the run button, you will get again an error, but this time the error is different. And this is because we have added the dataset, which is sample.csv, inside the data directory, but this dataset needs to be passed via the command line. And to add the parameter in the command line, go to edit configurations in the run, and inside the parameters option, provide the path where your file is present along with its extension. And then click apply and click OK. Now it should be good to go. Once again press the run button. It is going to take some time, and after a while you will see that it is going to display us the data that we displayed using our code. So it has returned us three countries: United States, Canada and United Kingdom, and the count of the values for each of the countries. So the United States count is 4, for Canada it is 2, and for United Kingdom it is 1. So This displayed data shows that we have correctly configured our PySpark to run in our PyCharm community edition. So once you have done, you can use any of the code example to run. This is the one that I use. You can run any other example that you want to ensure that your PyCharm has been successfully configured. In this video, you will learn how to use Apache Spark in cloud on DataBricks. And for that, we will first create a DataBricks trial account. Then we are going to create a Spark cluster. Then we will create a notebook. And then finally, we are going to execute the Spark code into our notebook. We'll start by creating a free DataBricks account on the community edition, and for that go to databricks.com, and once you land on this page you have to click try DataBricks. Then you have to provide all the information that is needed and then click continue. And once you click continue, here you have to choose a cloud provider. You can either choose AWS, Microsoft Azure or GCP, and instead of clicking continue you have to select get started with the community edition. The email address you provided will receive a link. Follow the link and then finally you will land on this page. So this is going to be the look of your DataBricks community edition. Let's explore it a bit. In the left navigation menu, you can see that we have multiple options of creating the components, data, compute, workflows, etc. So we'll start by creating a cluster for our Spark. For that, click create and then from here select cluster. Once you land on this page, you have to provide a cluster name. I am going to call it Spark 4 and then you have to select DataBricks runtime version. From these different versions, you can select any of the ones. Since I am using Spark 3.4.0, so I am going to use this version. You can select any version that you want and then click create cluster. Once you click on create cluster, it is going to take some time for cluster creation and I'll come back when the cluster is created. Okay, so you can see that our cluster named Spark 4 has been created. It has an active memory of 15 GB, active cores are 2 and 1 active DPU. So once your cluster is created, the next step is to create a notebook, and for that once again click create and then select notebook. And you can see that your notebook has been created, but right now the default language is Python. You can select any language you want. I am going to select SQL for this video. So now I am going to execute certain Spark queries inside the notebook, and to do so I am going to go to the DataBricks docs, and once you scroll down a bit you will have all the steps of how to use DataBricks as a beginner. And we'll firstly create a Spark table from the CSV data. For that I am going to copy this command and I'm going to paste it inside my DataBricks. Okay, so what this query is doing, it is creating a table diamond using the CSV file, and this CSV file is already present inside the DataBricks on this particular path. Okay, so let's execute it. You can either execute it by pressing shift and enter, or you can run it using this play button or the run button. Execute it. And you can see that it has returned us okay. This means that the command has been successfully executed. Okay, now let's add another one. This can be done by clicking this plus button. Okay, so once the table is created, now we have to query the data, and for that scroll down a little bit, and this is the query to view the data or to select the data from the table that we just created. So I'm going to paste it here. So this query is going to select color average price as price from the table diamonds that we just created, and we are going to group it by color and order it by color. Okay, let's execute it, and you'll see that it has returned us the output having different colors and the average price of each of the color. Apart from that, the DataBricks also allows us to visualize the data, and to do so you can click this plus sign and then select visualization. So once you click visualization, you will have different options for the visualization type. Either you can select a line chart or a bar chart, a pie chart, or any other area that you want to visualize your data. You can also customize it by selecting the columns for the X and Y axis and then simply click save. So this is going to display you the data in a visualized format showing which color has the highest average price and which color has the lowest average price. And just like we executed simple select statement, you can perform different updation and deletion on this data just like you can do in any other language. And this is how you can use Apache Spark on Cloud on DataBricks Community Edition. In this video, you will learn how to set up a single node Spark and running it in local mode from the command line. And to do so, first we are going to download the Spark binaries. Then we are going to start the Spark command line shell and test installation. Then we are going to download and install the WinUtils. And then finally, we are going to set up the Hadoop home and run the PySpark. So the first step is to download the Spark binaries, and for that you have to go to the link spark.apache.org. Once you land on the page, click on the download tab, and here you have to select a suitable Spark version, a package type, and then select the Spark compressed format. Here I am going to go with the latest release, which is 3.4.0, and then I am going to click on this download Spark link. And once you click on it, you will land on this page. Click on this particular link and your download will be started. Okay. And once your Spark is downloaded, right click it and extract the contents here. Okay, so now your Spark has been downloaded. Once you click on it, you can see that there are multiple folders inside a Spark folder, but the bin folder is the place where all the command line tools are present. Let's click on it, and here you will see two versions of each of the command. First one is a shell script and the other one is a CMD file. I'll be using the CMD one since I am working on the Windows operating system. The shell script can be used on the Linux operating system or Mac OS. Okay, let's go back, and you can see that there are other directories as well, but let's not worry about them at this stage. I'm going to move this directory to another drive. I'm going to move it to my F drive. Okay, so the first step completes here. The next step is to download the Spark Shell command line tool and test the installation. I'm going to open the command line from this directory so that the CMD opens from the current directory, but you can also open it from any other location and then use the CD command to navigate to your current directory. Now I'm going to try to run the Spark shell, and for that I'm going to write the command Spark shell. And once you click the enter, you will see that it has returned us an error saying that it did not find the winutils.exe java.io.file not found exception. Hadoop home is not present. Okay, so if you were running the Spark shell on the Linux or the Mac OS, then this command should run fine. But in order to run this on the Windows, you need the winutils. And to do so, you have to go to your browser, and from here you have to go to the following directory on GitHub representing the following winutils, and from here you have to download your required winutil directory. This is the one that I am working with, so I am going to download this one. I have downloaded the winutils and I have copied it inside the Hadoop folder inside my F directory. You can find it here showing the winutils.exe file. So this marks the completion of our second step, which was to download and install the winutils. Now we are moving towards the next step, which is to set up the Hadoop home. And the Hadoop home should point out to the home directory of winutils. And to do so, go to your Hadoop directory and copy its path. Then you have to open the command prompt from the current directory in which you are working. So type cmd and you will be redirected to here. Now you have to write a command setx hadoop underscore home, and then you have to paste the path where your winutil directory is present. Okay, then press enter and you can see that the specified value has been saved. Now close it, and we can also verify it if the path has been successfully set or not. Once again, open the command prompt and type the command echo hadoop underscore home, and then the dollar sign. And you can see that the path has been set. And now we can run the Spark shell once again, and for that go back to your Spark directory and inside the bin folder open the command prompt from here. Once the command prompt is open, now we can run the command Spark shell. And you can see that now it has run without any errors. But this series is all about Spark programming using Python, and the Spark Python shell is known as PySpark. But here you can see that the current default started shell is the Scala shell. So the PySpark requires Python in order to run it, so you must have Python in your system. Let's check whether the Python is present or not. Quit from the Scala, and once again here I am going to type PySpark to see it runs or not. And you can see that it has shown me the version of Python, which means that Python has been installed in my system. But if you do not have Python, I recommend you to install any version of Python or Anaconda in order to use PySpark properly. And once I run the command spark.version, it has shown me that the Spark version installed is 3.4.0, which is the one that we just downloaded in the beginning of this video. Hi, welcome back. In this video, we are going to talk about Spark program execution. Executing Spark program is not so simple and straightforward. You must have good sense of Spark architecture and execution model. Let's start with a straight question: how to execute Spark programs. We have two methods to run Spark programs: interactive clients and submit job. Interactive clients include Spark Shell and web-based notebooks. They both provide you easy method to run Spark programs. Both of these will allow you to run your Spark code line by line and get the output back on your console. Most of the people use it for learning or during development phase. They are best suited for exploration purpose, but ultimately all of your exploration will end up into a full-fledged Spark application. On the other hand, the submit job method is used for production use case. Apache Spark comes with Spark Submit utility, which allows you to submit your jobs to the cluster. In future videos, I'll show you how to use Spark Submit and various options offered by the tool. So the submit job includes Spark Submit, DataBricks notebooks, and REST APIs. So you got the answer to the main question: how to execute Spark programs. You can run your Spark application using one of the following methods. The Spark Shell and Notebook are prime interactive tools, whereas Spark Submit is a prime tool for submitting your Spark program to the cluster. We use interactive clients for learning development and exploration, but the real life production implementation is all about packaging your Spark application and submitting it to the cluster for execution. However, most of the Spark vendors are going to offer you some other alternatives. For example, DataBricks Cloud will allow you to submit the notebook itself, and you do not have to package your application and use the Spark Submit tool. Most of the cloud vendors will allow you to use REST APIs or a web-based interface to submit your packaged Spark application, and they internally take care of running the job on the Spark cluster. All these methods are vendor specific, but Spark Submit is a universally accepted method and works in almost all cases. That's all for this lecture. I'll see you in the next one. Welcome back. You already learned that we develop Spark applications and submit them to Spark cluster for execution. However, we still don't know how Spark is going to execute our application on a distributed cluster. And that's exactly what we are going to discuss in this video. Spark is a distributed processing engine. So let's see how the Spark distributed processing model works. The Spark applies a master-slave architecture to every application. So when we submit our application to the Spark, it is going to create master process for your application. This master process is then going to create a bunch of slaves to distribute the work and compute your job. You can think of these as runtime containers with some dedicated CPU and memory. In Spark terminology, the master is a driver and the slaves are the executors. But remember, I am not talking about the cluster. The cluster itself might have a master node and a bunch of slave nodes, but those things are part of the cluster and are managed by the cluster manager. I am talking about your application and the containers. So the Spark engine is going to ask for a container from the underlying cluster manager to start the driver process. Once it is started, the driver is again going to ask for some more containers to start the executor processes, and this happens for each application. So the point is straight. Every Spark application applies master-slave architecture and runs independently on the cluster, and this is how Spark is a distributed computing platform. That's all for this lecture. I'll see you in the next one. Hi, I am Aliza Tanveer from SkillCurve. In this video, you will learn how PySpark works in local client mode, which is the Spark shell, and how the drivers and executors are created in this mode. And for that, we will first open the Spark shell, then we will create a request for the resources, which are the threads and the memory. Then we are going to execute the job in the shell, and then finally we are going to monitor the metrics using Spark Context Web UI. Before moving towards how the PySpark works in local client mode, which is the Spark shell, let's first look at the Spark shell help. And for that, go to the directory where your Spark is installed and then go to the bin folder, and from there you have to open the command prompt so that the command prompt starts from that path. Then we have to run the command of PySpark help. You have to write PySpark minus help, and once you press enter, you will see different options for the PySpark. So the PySpark shell gives you lots of options. The master option is used to tell the Spark shell about the cluster manager. We want to use the local, and that is the default value. However, in this video I am going to use 3 threads. The default star value allows the Spark to create n number of threads depending upon the resource availability. So here I am going to provide 3. Then the next thing that we are going to use in this video is the deploy mode. The deploy mode's default value is client, and that's what we want. You have many other options here, but let's not dig into them now. But another thing that we need in this video is the memory, which is this one, driver memory. Okay, so the default JVM heap size is approximately 1 GB in most cases. In this video, I am going to give it a sum of 2 GB. Now we are all ready to write our Spark shell command. We are going to ask for 3 threads and 2 GB memory. And for that, I am going to write this command here. I am using PySpark and the master tag to define that I need 3 threads, and for the driver memory, I am requesting for 2 GB memory. Press enter, and you can see that it has executed successfully and we are inside our Spark. So now I am going to execute 2 commands. Firstly, I am going to use this command in which I am using the DataFrame object, inside which I am reading a CSV file which is present on my local system, and I am using the Spark to read the file. Press enter, and once the command will be executed, the next thing that we are going to do is to display the data which is loaded inside the DataFrame object using df.show. And once you press enter, you will see all the data which was present inside the pets.csv file. Okay, so Apache Spark is a well-defined system and it generates lots of matrices, logs, and other information to monitor and investigate things about your application. You can see some of it via Spark Context Web UI, and here is the URL. Once you land on the page, you will see a timeline. The Spark started and executor driver is added. Here you do not see the drivers and the executors separately because we are in the local cluster and everything is running inside a single JVM. And JVM is a combination of driver and executors, and that's what we see here, which is just a single process. Okay, so since we asked for 3 threads, and here once you click on the executors tab, you can see that all we have is one driver and 3 cores, and that is the number of our threads. So this means that Spark has successfully executed our command to grant us 3 cores and 2 GB memory, out of which only 912.3 MB is used. But the 2 GB was defined for the overall execution of the JVM. So this is how you can use the PySpark in a local client mode using the Spark shell. That is all for this video. Thank you. In this video, you will learn how to create a multi-node Spark cluster using GCP. Spark is a distributed cluster and you may want to access the real distributed cluster for exploring how things are going to work in a real distributed cluster. And for that, we will first open the GCP console and create a DataBricks cluster. Then we are going to select the configurations for the master node. After that, we will select the configurations for worker nodes, and then finally we will create the cluster. You should have a Google Cloud account and it is a paid service, but Google also provides free credits for the first timers. Once you have a GCP account, go to your console homepage and you will see a dashboard similar to this. Click on the GCP menu and select DataProcks. DataProcks will be present inside the analytics part of the menu. Scroll down a bit and once you move into analytics, select DataProc and then select clusters to create a DataProc cluster. Google DataProc is an on-demand yarn cluster which comes with Spark setup. If you are using it first time, it is going to show you the message that DataProc API has not been enabled, and then it will redirect us to the API management dashboard to enable the Cloud DataProc API. And once the DataProc API is enabled, you have to click Create Cluster button. And it is going to ask you whether you want to create the cluster on the compute engine or on the Google Kubernetes engine. I am going to select compute engine. And once you land on this page, you have to follow certain steps. First, you have to provide a name to your cluster. I am going to call it my yarn cluster, and you can give any name to your cluster you want. Then we have the location in which you want to select the region and a zone. I am going to go with the default values that GCP has set for me. Then you have to select the cluster type. For the cluster type, I am going to go with the standard one, having one master node and n worker nodes. After that, scroll down a bit. No need to change the policy for auto scaling. Leave versioning as it is, and the only thing that we need to change here is the component gateway, and we have to enable the component gateway because it will provide us access to the web interfaces of default 10 selected components of the cluster, and we can access the Spark UI and the history server. Then for the optional components, I'm going to select the Anaconda and the Zeppelin notebook, which is similar to DataBricks. Okay, you can select any other option that you want, and once you do this, go to the next point, which is to configure the node. Here you have two types of nodes. One is the master node or the manager node, and the other one are the worker nodes. Here we have to select the series. You can select E2, N2 or any other you want. I'm going to go with the default one. Then we have to select the machine type for the master node. I am going to go with the standard one, having 2 core CPU and 8 GB memory. Then primary disk size is a lot. I am going to change it to only 32 GB. Then we have to provide the same information for the worker nodes. For the worker node, I'm going to go with the standard one, having 2 CPUs and 8 GB memory. Then we have to define the number of worker nodes. I'm going to have a 4-node yarn cluster having a 1 master and 3 data nodes. So here instead of 2, I am going to provide 3 to provide 3 data nodes for it. Then once again, I'm going to change the disk size to 32 GB because I don't need that much memory. And then leave all other things as it is and simply click create. And once you click create button, it will take some time for the creation, and after a while your cluster will be created and it will be ready to use. After a few minutes, you can see that our cluster has been successfully created. Let's go inside it, and here you can see the cluster dashboard showing you the yarn memory, the yarn pending memory, and the node manager, etc. These matrices are going to change once we will use the cluster. Okay, so let's click on the VM instances, and you can see that right now we have 4 virtual machines. In simple words, we can say that we have 4 nodes. One is the master node, and the other 3 are the worker nodes that we created while creating the cluster. Okay, so now you have created a multi-node cluster using GCP, and you can use this in further processing, which we are going to do in the future videos. And this is how you can create a Spark multi-node cluster on the Google Cloud platform. In this video, you will learn how to work with Zeppelin notebook in a cluster to execute PySpark. And for that, we will first open the Zeppelin notebook. Then we are going to set the interpreter directive to PySpark. Then we are going to execute a job which is actually some PySpark commands. And then finally, we are going to monitor the metrics. In the last video, we left off at creating the cluster having one master node and 3 worker nodes. So now we are going to move forward. Firstly, we will go to Web Interfaces tab, and from there you have to find the Zeppelin notebook. Once you select the Zeppelin notebook, you will land on a page looking like this, and then you have to create a notebook inside the Zeppelin, and for that you have to click Create New Node. Here you have to provide name for the notebook. I am going to call it My Notebook, and then you have to select the default interpreter. By default, it is Spark. You can select anyone that you want. Okay, and then click Create. Once you click Create, a notebook will be created. A notebook is not like a shell which immediately establishes a connection with the drivers and the executors. Instead, it is just a web UI which is not yet connected to the cluster. And you must run some special commands to initiate the connection, and it could be as simple as running the Spark version. So if I try to run a Spark query here to find the Spark version, and once I execute it, you will see that it has returned us the result 3.1.3. However, the spark.version command is executed as a Scala code. This is because the default Zeppelin notebook cell is a Scala cell, but we want to use PySpark, and to do so we need to add a line in the beginning of the cell. And to do so we need to add this line in the beginning of the cell. This is an interpreter directive for the cell to ensure that the cell is considered as a PySpark shell. Now after this, you can run Python or any PySpark code that you want. I am going to simply run a command, and you will see that now it is going to execute it as a PySpark code instead of a Scala code. This code that we just executed is called a job, and now you can go to the Spark history server to view the history. And to do so, you have to go back here, and then you have to select the Spark history server. Once you land on the page, you will see that it has not shown us anything because the history server is not going to show us the currently running application. So what else can be done? Go back, and from here you have to select the Yarn resource manager, and it will show you the Zeppelin application. Once you land on the page, you can see that we have a Zeppelin application running. And once you scroll a bit to the right, you will see the application master tracking URL. Once you click on it, it should take you to the Spark context UI. So here we have the job timeline for it, and you can see that we have got a one driver and 2 executors. However, you can see that the executor 2 is already released by the Yarn dynamic resource allocation policy, and that is why the executor 2 has been removed. So this is how you can use the Zeppelin notebook inside the cluster to execute PySpark. That is all for this video. Thank you. Welcome back. In this lecture, we are going to take our next step in Spark programming and talk about data frames. So let's start. Spark is a distributed data processing framework, and typical data processing is a 3-step process. First is to read the data. Next step is to process it according to your business requirements, and then finally you write the outcome of your processing. Spark DataFrame is a two-dimensional table-like data structure that is inspired by Pandas DataFrame. They are distributed tables with named columns and well-defined schema. That means each column has a specific data type such as integer, float, string, timestamp, etc. You can visualize your data frame as a database table, and most of the operations that you are going to perform on these data frames are also similar to the database table operations using the rows and columns. So, if you have already worked with databases in SQL, then you are going to feel at home with the Spark data frame. So now you know that a data frame must have two things, a column name and schema, and you can use the data frame to read or write the data. Let's talk about the features of data frame. So a Spark data frame has following features. It has an ability to process the data in the size of kilobytes or petabytes in a single node cluster to large cluster. Then it also supports different data formats like Avro, CSV, Elasticsearch, etc. and different storage systems like HDFS, Hive tables, and MySQL, etc. Moreover, it provides state-of-the-art optimization and code generation through the Spark SQL Catalyst Optimizer, and it can be easily integrated with all big data tools and frameworks via Spark Core. And lastly, it provides API for Python, Java, Scala, and R programming. So this is all about data frame. In this video, we are going to create a Spark project and define our project's build configuration. And to do so, firstly, we will create a new project on the PyCharm. The next step will be to set the Python interpreter. Then we are going to download and install the dependencies required for PySpark. And then finally, we are going to write and execute the Python code to see that everything is working correctly. Let's start the PyCharm RDE. We are going to create a new project. Give a suitable name to your project. I am going to call it Hello Spark. Okay, so once you have given the name to your object, the next step is to select the Python interpreter or the virtual environment. I am going to go with the version of the Python that is installed into my system, which is present on this part. So this is going to be my base interpreter. You can use any virtual environment, either the Anaconda or any other that you want. Then all you have to do is simply uncheck this button and then click create. The project creation is going to take some time for creating the virtual environment. You can see that your project has been created and the environment has been set. But before we do anything, let's install some necessary packages. And for that, go to file and from that select settings. Once you are in the settings, you have to select your project name and from that you have to select Python interpreter. Once you click on Python interpreter, you will see something like this. These are the predefined dependencies of the project. I am going to add two new dependencies. Firstly, I am going to add the dependency for the PySpark since we are going to use PySpark in our project, and click install package. And you will see that the package PySpark installed successfully. Then we will also install PyTest. And for that, I am going to type here PyTest and I am going to click install package. And the package PyTest also installed successfully. So let's close it and you will see that in addition to PySpark and PyTest, some other dependencies has also been downloaded. These are required by these two dependencies. Okay, click OK and this will be closed. Once this is done, let's create the main file now. For that, right click on your project name, select new, and from here you have to select the Python file. And I am going to call it Hello Spark, which is the name of my project. You can give any name to your file and it is going to be a .py file. So we will start writing the code into this .py file. We'll start by writing from PySpark.sql import everything. You will need this line in every Spark code because it is needed whenever you need to execute Spark in Python. Okay, so once this is done, I am assuming that you already know Python, so I'm creating the main entry point of the PySpark program and then I'll print a message from it. So I'm going to do so. I am going to create
the main entry point of my program, and once I am done with it, the next thing I am going to do is to print a suitable message that will be displayed if our program executed successfully. Oops, there is a typo. Let me correct it. And this is the entry point. Now I am going to use the print command to print a suitable message. I am going to print hello Spark with an exclamation mark. Once this is done, now let's execute it to see whether the program has been configured correctly or not. And you will see that hello Spark with an exclamation mark has been printed on the screen, which means that we are now ready with a basic project template with all the required dependencies and the main entry point. From the next videos, we will create the log4j.properties file for other configurations, and then finally we are going to use the DataFrame object for reading and writing data in Spark. That is all for this video. Thank you. Hi, I am Aliza Tanveer from SkillCurve. In this video, we are going to configure the Spark application log. So for that, we will first create a log4j.properties configuration file, and then we will configure the Spark to pick up those log4j configurations. In the most basic setup, log4j has three basic components: logger, configurations, and appenders. The logger is a set of APIs which we are going to use for our application. Configurations are defined in the log4j.properties file and they are loaded by the loggers at runtime. And appenders are the output destinations such as console and log files. These appenders are also configured in the log4j.properties file. The Spark project is using log4j, and you might be wondering, why don't we use the standard Python log? I'll answer this question in a minute, but before that, try to understand how we can use the log4j with PySpark. We'll start by adding a log4j.properties file in the root directory of the project. I already have a pre-configured log4j.properties file. Let me add it here, and after pasting you will see something like this. Let's look at the file's content. The content of this file is pretty much standard, and let me quickly explain a few things. Log4j configurations are defined in hierarchy, and the topmost hierarchy is the root category. So I have defined the root category at the top. For any hierarchy or category, you have to define two things. The first thing is the log level, and the second is the list of appenders. Log4j supports multiple log levels such as debug, info, warn, and error. I am setting the root category as warn. So at the topmost level, we only want to see warnings and errors. We do not want to see the info and the debug messages. And we want these messages to go to console. So I have set the appender as console. The next thing to define is the console appender. All these configurations are standard and they remain the same in most of the projects. So these two sections together will set the root level log4j configuration, and they will stop all the messages sent by the Spark and other packages except warnings and errors. So in this way you will get a clean and minimal output. However, we want to change the behavior of our application. So I am defining a second log level specific to my application. I am naming it skillcurve.spark.examples. This is the name that I will use while using the logger in my application. The application level log is set to info, and I want to send these logs to console and file appenders. We wanted to send the root level logs to the console only, but we want application level logs to go to the console and log file both. We already defined the console appender, so I'm setting the file appender here. The rest of the settings here below are some of the recommendations by the Spark log4j configuration template, so I am keeping them in my configuration file as well. That's all we have to do in the log4j configurations. However, I want to talk about these variables. I am using two variables here. The first variable is to identify the log file directory location, and the second one is to identify the log file name. All these log4j configurations are standard and they would work well for most of your projects. Only two things will be changed for each project. One is the application logger name, and the second one is the log file location and the log file name. You might be wondering why we need these variables. Can't we give a fixed location and file name? Let me explain. If your application is creating log files at some location other than the Spark Yarn application container log directory, Yarn is not going to collect it, or if your cluster admin forgot to define a value for this variable, Yarn is not going to manage the logs and you are going to struggle for receiving and reading your log files. The next variable is the log file name. We are using a variable name for the log file name because we want to control the log file name and do not wish log4j to give default and random name to it. We are going to run the application on our local machine, so these variables must have a valid value for the local setup as well. So now we will move to our second step, in which we will see how to configure a local log directory or the JVM variables. Spark has a complex mechanism to read configuration settings. Every Spark application will look for a Spark home variable. If you have a Spark home configured, then Spark will look into the conf directory of your Spark home. Let me show you. Here is my Spark home. So Spark goes in this directory, which is right here, and then it will go into the conf folder. Once it lands into the conf folder, this is the place where Spark will look for the configurations, and we are going to use the spark defaults.conf file to configure the value of our log4j variables. Let's open it. Spark is a JVM based application, right? And it is written in Scala and it runs in a Java virtual machine. So I am going to use spark.driver.extra java options configuration to pass on some variables to the Spark JVM. The first variable tells the log4j configuration file and the name. So the log4j configurations are defined in the log4j.properties file in the current directory, and that's why we added the log4j.properties file in the project root directory. The second variable sets the log file directory location, and the third one is the log file name. We are setting these variables in the JVM, but all these three variables will reach to the log4j logger. That's how log4j is designed. That's all. Simply save this file and close it, and you are all done. In the next video, we will see how we will use the logger in our PyCharm IDE.
In this video, you will learn how to create and configure a Spark session. And for that, we will first create a Spark session in the main.py file. Then we are going to set up the logger.py file. Then we will use the logger in the main file. After that, we will create the spark.config file. Then we are going to create utils.py file in which we are going to define our configurations, and then finally we are going to get the configurations from the spark.conf file at runtime. When you start the Spark shell or the notebook, a Spark session is created for you and it is available as a variable named Spark. However, when you are writing a Spark program, then you must create a Spark session because it is not already provided. Creating a Spark session is straightforward. You simply have to create a variable. I am going to call it Spark and use the Spark session object dot builder dot get or create, and simply you will get your Spark session. The Spark session is a singleton object, so each Spark application can have one and only one Spark session. The Spark session is highly configurable. Let's set some configurations. The most commonly used configurations are master and app name. So you can simply press dot here and you will get app name, config and master. But we also have an overloaded config method for other applications. So let's first define the application name. I am going to call it Hello Spark and you have to write it in the double quote since it is a string. Then you have to place this backslash. The other thing we want to define is the cluster manager, and we have learned that the cluster manager config is defined as a Spark master. So we are going to use the master here, and inside this master I am going to use local multi-threaded JVM with 3 threads. So I'm going to define it like this and enclose all this in a double quote. We have created a Spark session, and that means that we have created a Spark driver. and we will use this driver for some data processing. And once we are done with the data processing, we should stop the driver. Place a backslash here too. And to stop the driver, we simply use the Spark object and then use the stop function to stop the driver. And that is how a typical Spark program is structured. In the earlier video, we configured log4j for this project. However, we still don't know how to use log4j to create the log entries. Let's do it now. I want to create a new class for handling log4j and expose simple and easy to use methods to create a log entry. So let's create a new Python package. For that, right click on your directory, and from the new option you have to select a Python package. I am going to call it lib, and once the Python package is created, then we have to create a Python file in it. I am going to call it logger.py. Now I will create a new class called log4j inside the logger. Then we will create a constructor for it, and I am going to pass the self. We will require a Spark session, so I'm going to take it as the constructor argument. Let's pass the Spark object here, and this is our constructor definition. I want to get the log4j instance from the Spark session JVM, and this is how you can get log4j instance from the Spark JVM. Now I'll create a logger attribute, and I'm going to initialize it with log4j.logmanager.getLogger method. And that's all. We have the logger, and we can use this logger to log the messages. But to make things more simple, let me define some easy to use methods. Like for warning, simply pass the message to the logger warning method, like so. I have defined a method for warning in which I have passed the object and the message, and simply I am going to pass this message to the warn method of the logger. And similarly, we can create methods for info, error, and debug. We are almost done. Let's go back to our log4j.properties file. And if you look at it, do you remember this name? My logger should be targeting to this name, and only then all the configurations will work. But how to target this name? It's very simple. Pass this name to your logger in the constructor. So I'm going to copy this, and once again go back to your logger.py file, and inside the getLogger method you have to pass this name. But I don't want to hardcode my application name. I have a Spark session, so I can go to Spark context, and after that I can simply append the name of my application with this logger name. But I don't want to hardcode my application name. I have the Spark sessions, so I can go to my Spark context and get the config and store it in a variable called conf. Once I have the config, I can query the target Spark app name, and I will get the logger in result. Okay, so this function is going to get the Spark app name, and it is going to store it in the variable called app name. Let's paste it above this line. Okay, and then you can simply append this variable app name with your logger name. And we are all done with the logger.py file. Now go back to your main class. This is my main class. Now we can get the logger like this. Once you have the logger, you can use it wherever you want. I am going to push one info message in the beginning and one info message at the end. Before running the application, I am going to remove this import here because we don't need it now. So in this application, we are simply creating a Spark session. We are going to send two messages to the logger, and then we are simply stopping the Spark session. Let's execute this. Great. We get the log messages on the console, but I also got this warning. But it's fine, you can ignore it. If you look at your project explorer now, you will notice an apps log directory. And if you remember that we configured our log4j appender to create log files in this directory. Apache Spark is a highly configurable system, and Spark allows you to set those configurations using 4 different methods. The first approach is to set the environment variable so that your Spark application will read and infer some information. We have already seen this in the previous videos. The other place to configure your Spark is the sparkdefaults.conf file. We use this one as well. The first two options are for cluster admins, and the third and fourth option are for the developers. Let's talk about Spark Submit. We have already used Spark Submit in our earlier video. It allows us to configure the application using command line options such as --master. We have already seen that in action in the previous video. The last method is to code the configurations in your application, and we have used this as well. You can set whatever config you want. You simply have to create a Spark config session, import the library, and now you can use the set method to set the app name config. You can set as many configs as you want, however, you must know the actual config property name string. For example, the Spark application name config string is spark.app.name. So after that, we will pass the application. Similarly, Spark.master is the string config name for the Spark master. Once you have the Spark config ready with all the desired configurations, you can simply pass it to the session builder. And to do so, simply press dot here config and then pass con equals con. And once you are done with it, now you don't need these two lines here. Simply remove them and add a backslash here. But I am seeing a problem. All these configurations are hard coded in my application. In some cases, you may want to avoid hard coding configs and may keep it outside the application code. But how do you deal with it? The first approach is to keep these configurations in a separate file and load it from the file at runtime. Let me show you. I am going to create a Python config file called spark.conf in my root directory. For that, right click on it, select new and then select file. I am going to call it spark.config. Now I can create a section and place my configurations in the file. Let's keep only 2 configurations for now on. I am keeping them as a key value pair separated by an equal to symbol. Now come back to your code and create a new Python file in the lib directory that we created earlier. I am going to call it utils.py. Firstly, I am going to import these two header files. Then I am going to create a function called getSparkAppConfig. This function will load the configuration from the spark.conf file and will return a Spark config object. Let's finish the function body. Create a new configuration object and read the configurations from the file. This is the file from which we are going to read the configurations. Then loop through the configs and set it to the Spark config object, and then finally return the Spark config object. So we have a function now. This function reads the configurations from the spark.conf object and returns the ready to use Spark configuration. Now we need to come back to our main file and use it in the spark builder.config method. Here, instead of these 3 lines, you have to type config equals to get spark add config. It is going to ask you to add the library and you simply click on import. We have fixed the hard coding problem. Now you can add more and more configs in the spark.config file, and your application will load it at runtime and use them to configure your Spark session. So go back to the Spark config. I am going to add another configuration here, which is going to be the app author, and I am going to provide the name Eliza here. Okay, then go back to your hello spark.py, and in the main file I am going to write these two commands. Firstly, I am going to get the configuration using the spark.sparkcontext.getConfig file, and then I am going to display it in the logger.info as in the form of a debug string. Okay, now let's execute it. Upon running, it is given me an error and it says that no section found. And if you go to the your utils.py, you will see that here I have passed spark.conf and the file name is spark.config. I am going to call it spark.config. Let's run it again, and you can see now it hasn't given me any error, and you can see that it has read the configurations from the file, displaying the app.author name and all other configurations. So this is how you can create and configure a Spark session in your PyCharm IDE. Apache Spark started with the goal of simplifying and improving Hadoop MapReduce programming model. To achieve this goal, Spark came up with the idea of RDD. The notion of RDD was revolutionary and it created the core foundation of Apache Spark. However, Spark didn't stop at the RDD and came up with a higher level of APIs such as dataset APIs and DataFrame APIs. To simplify our life, they also come up with a SQL layer and a Catalyst optimizer. So, all these data processing tools can be visually arranged as shown in the figure. So, what does it mean? Simple, the RDD is at the core. You can use RDD APIs to develop your applications. However, it is the most challenging tool to run and use. They offer you some additional flexibility, but they lack all the optimizations brought to you by the Catalyst optimizer. The next one is the Catalyst optimizer. We write code using Spark SQL DataFrame APIs and Dataset APIs. This code is then submitted to Spark for execution. Before that, the code passes through the Catalyst optimizer, which decides how it should be executed and lays out an execution plan for it. Finally, the Spark SQL, DataFrame APIs, and Dataset APIs are your preferred choices. I recommend you to prefer them in left to right order, which means Spark SQL is the most convenient option to choose. So you should prefer using it wherever applicable. The Spark SQL is an excellent choice and it can do a lot of work for you. However, a single SQL expression or a SQL script with a series of SQLs may not be helpful in some scenarios. You do not get some of the necessity facilities like debugging, implementing application logs, unit testing, and other obvious capabilities that a programming language brings to the table. So, you will be using Spark SQL to catch some low hanging fruits. However, a sophisticated data pipeline is going to push you to use DataFrame APIs and rely more on your favorite programming languages, and that's where the DataFrame APIs are your obvious choice. The last one is the dataset APIs. The dataset APIs are the language native APIs in Scala and Java. And what do I mean by language native? Well, it is simple. These APIs are strongly typed objects in your JVM based language such as Scala, and they are not at all applicable in dynamically typed languages such as Python. So, we are going to skip dataset APIs in this course and will focus on data frame APIs. Now, you have a high level picture of different types of APIs.
In this video, you will learn how to read a CSV, JSON and Parquet file using DataFrame object in Spark. And for that, we will first create a DataFrame object. Then we are going to define the file format which we want to read. Then we will define the location where our file is present. Then we are going to read the file in the DataFrame object. And then finally, we are going to display the data present inside the DataFrame object. I have created this new example Spark Schema demo. Most of the things I copied from the earlier example. However, I have included three data files in this project. The first one is a CSV file with more than 400,000 records of flight timings. The second one is also the same data, but this one is a JSON file. Similarly, the third one also have similar data, but it is a Parquet file. Here is my main file. I already have done some basic setup. I am not going to repeat it here because you have already learned all of these things in the previous video. Let me use the data frame reader to read the CSV file. We start with the Spark session and use the read method. The next thing to specify is the data source format, which in my case is a CSV source. After that, I will give some necessary options. My CSV file contains a header, so let's set the header to true, just like I did here. Then I am going to specify the file path. The file path can be any path of your local system or inside your PyCharm. So I am going to provide the path of the file where it is present, which is inside the data directory with the name flighttime.csv. So flight and a star means it is going to read all the files having the extension CSV and with the title starting from flight. So now we are ready to load the data to a data frame. Here I am not giving any schema and I am not even asking the data frame reader to infer the schema. Let's see what I get when I display the records. Let me show 5 records from this data frame object. After that, I also want to know the default data frame schema. So I will log the data frame and then convert it into a simple string. After that, simply run and let's see what we got. Oops, I've placed a long slash. So convert it to backslash and then run it. Upon running, you will get the first 5 records present inside the data frame which we read from the file. But inside the schema, you will see that it is showing string data type for all the columns, whether they contain integer values or the date values. This is because we haven't explicitly defined the schema. Let's try inferring the schema. So I am setting the option to infer the schema. And once I set it to true, I am going to run it again to see whether now the data types displayed for each of the column are correct or not. After setting it to true, let's run it to see the new output. Once you run it again, you will see that now the output is a little better. It is giving integer type for the columns having numeric values, but if you look closely, it is still giving string type for the columns representing the dates. So the point is straight. You cannot rely on the infer schema option. Let's create another data frame to read the JSON file. I am going to copy and modify the same code. I am going to make certain changes to it. Here in all the parts I am going to change CSV to JSON. Similarly, I am going to change the format from CSV to JSON. The option file for both the header and the infer schema are not used in the JSON file, and then I am going to provide the path for the JSON file. And then once again I'm going to change the name of the object here and then also in the logger, and once it is done I am going to execute it to see the result. Let's see the results in the output. After running the code again, in the output I am seeing a similar behavior in terms of inference. Here the date column is still displayed as a string data type. We will handle this later. Now let's read the Parquet file. Parquet is a binary file format which comes with the schema information already included in the data file, so you do not need to define the schema explicitly. After modifying the file type to Parquet in all the parts, let's run it. Once the output is displayed, you will see that for the Parquet file, the schema is showing the correct data type for all the columns. That is, for the date column, it is showing the data type date. For the string column, it is showing string, and for the numeric values, it is giving integer data type. So this is how you can read CSV, JSON, and Parquet files using the data frame objects in Spark. In this video, you will learn how to create Spark data frame schema, and for that, we will first create a schema programmatically, and then we are going to set that created schema to the data frame reader for the CSV file. Then we are going to create another schema using the DDL string, and then we will set that schema for the data frame reader that we created for reading this JSON file.
In the previous video, we learned that schema inferring does not work for CSV and JSON files. So now we will explicitly set the schema for these two data frame readers so that they can provide the suitable data types. There are two ways of explicitly setting the schema. One is programmatically and the other one is using the DDL statement. In this video, we will see both of them in example. Firstly, I will define the schema for the CSV data frame, and for that I will use the programmatic method. My Spark data frame schema is a struct type and I am going to store it inside a variable. And this struct type is made up of a list of struct fields. And each of these fields contains a key value pair for all the columns and their data types. The struct field contains two arguments. The first one is the column name and the second argument is the data type for the column. Let me complete the schema, and after that I am going to import the files for the Spark data type. So the struct type represents the data frame row structure and the struct field represents the data frame column structure. Now I am going to set this schema to the data frame object, and then I am going to remove the infer schema option from it. Then simply run the program. Upon execution, you will see that now it is giving the date type for the date column, string for the string values, and integer data type for numeric columns. Now we will apply the DDL string method to create the schema for the JSON data frame object. The DDL schema is simple. You simply have to define the column name and the data type for each of the columns separated by a comma. Now I am going to set this DDL schema to the data frame object that we created for reading the JSON file. And that's it. Now run it again. Upon execution, you will see that now it is showing the correct data type for the column representing date and correct data type for the column representing numeric values. So this is how you can create the Spark schema for data frame using different methods.
In this video, you will learn how to write data using DataFrame Writer, and for that we will first add Spark Avro dependency to our project. Then we are going to create a DataFrame Writer and we are going to repartition the DataFrame Writer on the basis of certain number of partitions. Then we are going to write this partition data into Avro, and finally we are going to verify the output that the number of Avro files are equal to our partitions.
In this example, we are going to create an Avro output. Spark Avro does not come bundled with Apache Spark. So if you want to work with Avro data, then you must include an additional Scala package in your project. We are working in PyCharm IDE having Python, and it does not have a method to include Scala or Java dependencies. So how do we handle it? Do you remember the Spark's default.config file? Let me open it. Go to your Spark. Inside the conf folder, this is the file that I am talking about. Edit it, and I am talking about this file. We can use this file to add Java and Scala packages. Let me do it. So in the last line of the file, I am going to paste this command and then manage the indentation. So this configuration tells us that we want some jars to be included into our Spark application dependencies. And this is the Avro jar that we needed. Save this file and then you are done. Now you can read and write Avro files using your Spark code. Once you are back into this IDE, I have this Sparky data file which I am going to use as the data source, and we will be creating an Avro file after processing the data source. I have also created this Spark schema demo.py file. I have the main method which creates a Spark session and then reads the data source. We will write this data frame using the DataFrame Writer API and learn the mechanics. So let's write the data frame as an Avro output. So we start with the data frame and then use its write method to get the data frame writer. Then we will set the format, and for that add a backslash here, and then we have to set the format which is going to be Avro. After setting the format, the next step is to define the save mode, and this can be done by using the mode method, and we are using the override mode. Another most important thing is to set the output directory path, which can be done by this. Here we have used the option, and inside the path I am providing the path where I am going to save the Avro files. And then finally we are going to call the save method. And we are all done. And what do you expect when you execute it? This code is going to create one or more Avro files in the given directory. However, before writing in the directory location, this API call is also going to clean up the target directory because we are currently working in the overwrite mode. The save method in an overwrite mode is a two-step process. Clean the directory and then run the new file. So be careful while using the overwrite mode. And how many Avro files do you expect to be created? 1, 2 or 10? Well, it depends upon the number of data frame partitions. So if this data frame has got 5 partitions, you can expect 5 output files, and each of those files will be written in parallel by 5 executors. If you have 3 executors and 5 partitions, then they are going to share the 5 partitions among the 3 executors. So it could be 2 plus 2 plus 1. But how many partitions do I have? Let me check the number of partitions. This can be done using the following command. First, we will convert the data frame into an RDD and get the number of partitions it has. Great. Now let's run it. So here is my output directory. You can see three type of data files here. Let me expand it a bit. The Avro file is the data file and the .crc file holds the data file's checksum, and the success file indicates that the write operation was successful. And in the output you can see that I got two partitions. However, I have only one Avro file. So what went wrong? I was expecting two Avro files because I have two partitions here. So what we did is that we counted the number of partitions, but we do not know how many records we have in each partitions. Let me count the number of rows for the partitions. And here is the code for that. I am grouping the data frame object on the basis of partition ID and taking a count. It is going to ask me to import the function. So import this function here. Simple. Now let's execute it again to see what is the output. So the partition ID 0 has got all the records and we do not see any partition ID here. But we do have two partitions. The ID 1 does not show up because the second partition has got nothing, and that's why I got only one Avro output file. Now let's repartition it and see if we get multiple files. And to do so, this is the code. Here I am forcing it to make 5 partitions. We will again take a count by doing so, and this time we are going to write the partition data frame, which can be done with these lines of code. Here, instead of simple data frame object, we have used the partition data frame which stores the repartition, and now I am going to remove this part here because we are already writing the partition data frame. Great. So now let's execute it again to see the output now. Great. So now you can see that the repartition worked and I got 5 equal partitions. And once I see the output directory, you can see that I got 5 Avro files. That's all. So this is how you can use the data frame writer API to write the data and display it using Avro.
In this video, you will learn how to create a managed table and access the catalog. And for that, you will first create a data frame writer. Then we are going to save the data frame as a table in the Spark. Then we are going to convert the table to a partition table on the basis of two columns. And finally, we are going to transform the table using the bucket bar to limit the number of partitions.
I have created this Spark SQL table demo example. Most of the things are same as the previous examples. We are going to create a managed table in Apache Spark. Creating managed table needs persistent meta store. You already know that Spark depends upon Hive meta store, so we need Spark Hive for this example. I have also created a Spark SQL demo.py file having code for the Spark session and for loading the data frame. You have already learned all of this. We want to use the Hive metastore. So here I am going to enable the Hive support for our session, And this is required to allow the connectivity to a persistent Hive metastore. Great, so now we are ready to start working. I want to do one simple thing. Create a manage table and save my data frame into the Spark table. However, one question stands. Why do I want to save my data frame as a manage table and why not as a Parquet file? And what is the difference between the two? Let me explain. If you store your data in a managed table, then it will be available to a whole lot of SQL compliant tools. Spark database tables can be accessed by SQL expressions over JDBC and ODBC connectors. So it is better to store your data into the managed table rather than as a Parquet file. So now let's write the data frame into our table. And it is as simple as simply using the data frame and calling the data frame writer API. Then define the mode as override and then simply use save as table, and inside the parentheses you have to define a table name into which you want to store the data frame. This save as table method is going to create my flight data table inside the default database. However, I want to create it in some other database. But how to do it? You have two options. First is to prefix the database name with your table name. Simple. The second option is to access the catalog and then set the current database for the default session, and I am going to pass airline here. So now I can safely remove the database name from here. I am assuming that this database already exists, but for the safer side we are going to use this command to either create the database if it does not already exist. I want to do one more thing. Our catalog contains a lot of metadata, so I am going to use this catalog to display a list of tables present inside the airline database and then display it as a logger info. Now let me just run it and show you some essential things. Upon running, it is giving me error that it takes one. Okay, sorry, I made a mistake here. Instead of current database, you have to write set current database, and then you have to pass the airline here. Okay, now let's run it again to see the output. Great. So it is showing us the catalog information. It is showing us the table name, the catalog name, the database name, and the type of table that we created. And have you noticed these two directory here? This one is your Spark database warehouse. If you expand it, you will have a base directory for your database, and if you expand it to, then you will have a subdirectory for your table, and inside your subdirectory you will have the data file. And this one is your persistent metadata store. Great. So I have created Spark table, but I want to create a partition table. And to do so, let me add the partition by clause here. Here I am partitioning the table on the basis of two columns, origins and the OP carrier. Now let's run it again. Here you can see that it has overwritten my previous table, and now inside this table directory you can see that we have more than 200 partitions. This is because in the data source we have more than 200 origins. This is okay for now, but what if we had 200,000 different origins for the data source? So is it okay for you to have 200,000 different partitions? Absolutely not, right? So you should not partition your table on the basis of a column which has too much unique values. Instead, you can use the bucket by. Let me do it here. So I'm going to remove this partition by with the bucket by clause. By is used to limit the number of partitions. Inside this bucket by, I am going to place 5, so it is going to create 5 different partitions. So these 5 partitions are now called buckets, but I still want to partition my table on the basis of the same 2 columns. So I'm going to pass the two columns here. The first one is the origin and the second one is the OP carrier. Moreover, I'm going to change the format to CSV. Parquet is a binary format and it is the recommended format. However, I want to manually investigate the data. That is why I have changed the format to CSV here. Let me run it and see what happens. Okay, so now you can see that I have got 5 files which represents the 5 partitions or the 5 buckets, whatever you want to call it. The bucketing does not require a lengthy directory structure. It is as simple as data files. Let's format the data a bit more. So the bucket by can also have a sort by method to sort the data, and I'm going to sort the data on the basis of these two columns again. Let's rerun it again. Great. So now let's open one of the file. You can see that now the data is first sorted on the basis of the origin and then on the basis of the OP carrier. So this is how you can use the Spark SQL tables to store the data frame.
In this video, you will learn how to work with DataFrame Rows, and for that, first create a new cluster in the DataBricks, then create a new Spark notebook inside the DataBricks. After that, we will create a user-defined function to convert the date format. Then we are going to create an explicit structure schema. Then we are going to convert the schema to the data frame, and then finally we will pass the data frame to the user defined function and run it to see the converted date format.
The Spark data frame is a dataset of rows, and each row of a data frame is a single record represented by an object of type row. There are 3 specific scenarios where you might want to work with the data frame row object. And these are manually creating rows and data frame, collecting data frame rows to the driver, and work with an individual row in the Spark transformation. The first two scenarios are mostly used in unit testing or development. We will start by logging into our Databricks account and then creating a cluster by selecting the create option. Then we are going to give a new name to your cluster and then select the Databricks runtime. I am going to select the same one which I have on my local system, which is Spark 3.4.0, and then click create cluster. Once our cluster is created, we will move towards creating the notebook. For that, click create and select notebook. Now we are all ready to write some code here. I have created a new function. Let me show it to you. So this function is used to convert the date format. It takes a data frame object, the format type of the string, and then a field. Then it simply returns a new data frame by converting the type of the field to the specified date format. Let me import some necessary packages. Your IDE easily takes care of these things, but you need to be careful when using the notebook. Then simply run the cell. Now, in order to test the function, I need a new data frame. One approach is to create a data file and then load it inside the data frame and test its values one by one to check the function. However, this approach might slow down the processing if we have hundreds of sample files or a large number of records in it. So, for testing such functions, we are going to create a data frame on the fly, which involves creating a schema and assigning it to data frame. Let's create a schema. After defining the schema, we will then create a list of rows having dates in many different formats. Then we will simply create a parallelized RDD, and then we are going to create the data frame from the schema and the RDD that we just defined, and then simply run it. Once it runs successfully, then I am going to print the schema and the contents of the data frame. After that, I will call my user defined function in which I am going to pass the data frame object, the date format, and save it inside a new data frame object. And then finally, I am going to print the schema of the new data frame object and then display its contents too. Then simply run it. And once you execute it, you will see that the before data frame shows the string type and the after data frame shows the date type. and it has also converted the date into the specified format for all the different formats. And this is how you can work with the data frame rows. In this video, you will learn how to use data frame rows to perform unit testing. And for that, we will first copy the code from the notebook that we created in the previous video and convert it into the Spark project. After that, we will create a new Python file for the test cases. Inside this file, we are going to create a class and inherit it from the test cases. Then we are going to create a Spark session, the rows and data frame inside the file. Finally, we are going to create the test cases and run it to see the result. I have taken the code from the DataBricks notebook and I have converted it into a Spark project, and here it is. The name of the project is Row Demo. Here I am creating the Spark session, then I am initializing the logger. After that, I am creating a schema, then I am explicitly defining the list of rows, converting it to RDD, and then creating the data frame from the rows. And if you scroll up, here is my function. And here we are testing the function also. Let me run it to see the output. And it is running exactly like how it ran in the DataBricks notebook. I am manually observing my results and I know that my function works correctly, but I want to automate this into unit testing. And to do so, let's create a new Python file. Right click on your project, select new and then select Python file. I am going to call it row demo underscore test because it is going to be my test case file. We are going to create a test case using the Python unit test framework, and for that you must include unit test 2 in your project dependencies. So let me import it here. So we will start by creating a class and inherit it with the class test case. For unit testing of our code, we will be setting up our Spark session and data frame. And for that, let me create a class method and I am going to call it setup class, like so. The rest is simple. I'll first create a Spark session and import the required libraries. Then we are going to define the schema, and this schema is going to be same as the one that we did in the rowdemo.py file. Import all the required dependencies. Then we are going to create a list of rows, convert it into an RDD, and then finally we are going to create the data frame from the RDD and the schema. These are the essential requirements. Now I have a schema, I have a Spark session and a data frame object which I can pass for my test cases. Now I will create two test cases. In the first test case, I am going to be validating the data type, and in the next test case, I am going to validate the data itself. So I am going to create two functions representing the two test cases. Let me create the first test case. This is going to validate the data type. Inside the test case, we will call the function that we created to format the date. And this function is going to return us a data frame object. However, the actual data of the data frame is sitting at the executor, and the data frame is just a reference to the real data. So the point is straight that you cannot assert the data frame. And if you want to validate the data, then you must bring it to the driver. And this can be done in a simple way. How? By simply collecting the data frame. The collect method is going to return a list of rows to the driver. And once your data is at the driver, you can easily assert it. Let's do it. I am going to iterate over the list of rows, and for each iteration I am going to get a row and I am going to assert it. Here I am validating it for an instance of type date. So this function is going to test whether the data frame returned by the function is of the type date or not. Let's move towards our second test case, which is to test the value. Here again I am going to call the function and collect it as a list of rows. Then again I am going to iterate over the rows and then I will assert each record for the date value. That's it. Now let's run these test cases and see the result of both of these test cases. After execution of the test cases, you will see that two items were collected and these were the test data type and the test data value, and both of the test cases have passed. So this is how you can use the data frame rows to perform unit testing in Spark. In this video, you will learn how to work with the data frame columns. And for that, we will first create a new cluster in the DataBricks. Then we are going to create a new notebook and attach it with our cluster. After that, we will use the built-in dataset from the DataBricks inside the notebook. We will load the data into the data frame and then we will apply different column transformations on the data frames. We'll start by logging into our DataBricks account, and then we have to create a cluster. For that, click create and select cluster. Suitable name to your cluster. I am going to call it a column cluster, and then you have to select the DataBricks runtime version. I am going to select the one which is stored in our local system, and then I am going to click create cluster. While the cluster is being created, let's move towards and creating a new notebook. And our notebook has been created. The DataBricks Community Cloud comes with some predefined datasets. Let me show you. Paste this command here, and once you run it, you will see a bunch of clusters to play with. And from these datasets, I am going to use the airline data. Execute it, and you will see that inside the airlines data, there are also a large number of datasets. And you already know that the community edition is not capable of handling such large datasets. So I am going to use just one file from all of these. Let's view the data in the file, and for that I am going to write this command. Execute the command and you will see the data which is present inside this single file. And you can see that this single file alone has a large number of records present inside it. You can easily see that it is a CSV format data and it comes with a header row. And I can easily load it and infer the schema to create my data frame. Let's do it. And here is the code to load the data into a data frame object, which is going to be airlines data frame. The format is going to be CSV. We have defined the header option to be true. We are going to infer the schema, and this is the path where it is going to be present. And the sampling ratio has been set to very small value so that this command runs very fastly. Now let's execute it. So now we have a data frame containing the data which we can use to explore the column values. Spark data frame columns are objects of type columns. However, they do not make any sense outside the scope of the data frame, and you cannot manipulate them independently. Moreover, columns are always used within the Spark transformation. There are two ways of referring to a column in a data frame transformation. One is the column string and the other one is the column object. Column string is the simplest method to access the column. Here is an example. In this example, I am using the column name string. Here I am using the column name string with the select. You can use it with the drop, order by, update or any other operation. And you will get data for each of the column. And the second method is to use the column object. And it is a bit confusing because we have a lot of ways to create the column object. However, the most common method is to use the column or the call method. Here is an example. In this example, I have used three different methods to refer the column. And all three methods are the same. Ultimately, all three of them are creating the column object. The first one uses the column method, the second one uses the short form of the same method, and for the third method, there is a slight change. you have to add the data frame object name here dot distance, and it is accessing the column by its column name. Let's remove these quotes too. All of the three methods have the same meaning and the same effect, and it is entirely up to you to choose any of these. Let's execute it, and you will see that it has shown us the data for all the three different ways of accessing the column. Moreover, you can also use the column string and the column object within the same transformation. Let's change this example to see how we can use it together. So here I am going to use the column string along with the column objects to see how it works. Let's execute it. And now, in addition to these three columns, it is also showing us the year which we shown using the column string method. Now let's move towards to see how we can create the column expressions. Spark DataFrame offers multiple options to create the column expressions. However, you can categorize them into two main categories. The first one is the string expressions or the SQL expressions, and the second one is the column object expressions. And these two types are based on the earlier two types mentioned for accessing the column. Let's try to understand the first one. Let's assume I have this expression here. I am selecting three columns and I am using column string to reference the column. Let's execute it to see the output. In addition to all these columns, I want to add one more column for the flight day. I have three fields in the data frame for year, month, and day of the month. I want to combine these three fields and create a single field for the date of flight. If you know SQL, then you can easily create an expression like this. The expression is going to look like this. However, this is an expression string and not a column for the string. Try running it, execute it, and you will see that now in addition to the first three columns, the other three columns have been concatenated into a single column representing the flight date. Now we will try to convert this example into the column object expression. The first three columns are already using the object notation. Problem is the last part. Here the concat function is going to join these three columns into a new column. Then this new column is going to go to the toDate function, which is going to transform the column into this format, and the column name will be set to flight date and the top 10 results will be displayed. Let me run it, and it runs fine. Creating your expressions using the column object might look a little bit complicated. However, it is the same as building your expressions using the SQL statements. But if you practice it, you will master it just like you can easily master creating the SQL expressions. So this is how you can use the Spark data frame columns inside the DataBricks. In this video, you will learn how to create and use user-defined functions. And for that, we will first create a data frame and load data in it. After that, we will create a user-defined function for formatting the gender. Then we will register the function to UDF. We will use two approaches, one for SQL expression and the other one for the column object expression. After that, we will call the function for both the cases, and then finally we will display the results. Let's start. I have created a new project UDF demo, and I have created a directory data having the data survey.csv. Then I have the logger.py file, log4j.properties file, and I also created a UDF demo.py file. Inside this file, I have created a session and I have loaded the data into a data frame object, and after that I am simply displaying the data frame. Let's run this file to see the data present inside the data frame. And upon running you will have something like this, but if you see the gender column, it has gender in different formats. Sometimes it is showing complete male and sometimes only M is written, so we need to bring it to a specific format. I have many ways to do this transformation, but I am going to use a user defined function to format the gender into one format. Let's create a function. I am going to call it parse gender. It is going to take a string and it is going to return a string.
Inside the function body, I am going to use a regular expression to infer the gender. The first one is the regular expression for the female and the second one is the regular expression for males. Inside the regular expression, I have three patterns to infer the female gender. Let's quickly have a look at these patterns. First pattern means that the string is a single character. The second pattern means that it starts with an F followed by some other letter and the character M. And the third one starts with a W, has a character and ends with letter M. Similarly, the pattern for male gender is also defined. These patterns may not be the perfect match for the gender, but they work for the current dataset. Now let's test this expression, and for that here is the code. Here I am converting the gender to the lowercase and then finding it inside the female pattern. And if that string is found, then we are going to return the female. Similarly, again, we are going to convert the gender to the lowercase and match it with the male pattern. And if it is found in the male pattern, then we are going to return female. And if both of these scenarios does not match, then simply we are going to return unknown. My function is absolutely ready. Now we can use it. However, we have two approaches to develop the expression, the SQL or the string expression or the column object expression. We are going to see both the examples in this project. The first one is the column object expression. We need to register our user defined functions. So I am using UDF to register my function. And inside the UDF function, I am passing the name of my user defined function as the first parameter. And as a second parameter, I am passing the return type of my function, which is string. So collectively, this UDF function is going to register my function and it is going to store it into a new data frame object. I will define the column object expression in which I am going to use the with column function. The with column function is going to transform a single column without affecting the transformation of other columns. And inside this with column function, I am passing the column name and then I am using the UDF reference for the gender that I just created previously. Store the result in a new data frame and then I am simply going to display the top 10 records of data frame. Let's see how to use the user defined function with the SQL expression. The SQL registry is a bit different because now you have to register your user defined function as a SQL function and it should go to the catalog, which in case of the column object expression doesn't. In order to register your user-defined function in the SQL expression, you can use the Spark session.udf.register function, which takes three arguments. First one is the UDF reference, second one is the function name, and the third one is the function return type. After that, we are going to use the data frame object with the with column function, inside which we are going to define a column name gender, and then we are going to create an expression with the UDF and a column name. After that, we are going to verify whether our data has stored in the catalog or not, and for that we will see the catalog entry for both of the methods of creating the expression. Firstly, we will move towards the column object expression and we are going to use the logger info for this. Firstly, we will use the Spark session and the catalog to list all the functions. Then we are going to iterate through the list to see whether a function is present or not, and if it is present then we are going to display the logger info. Similarly, we are going to do the same for the SQL expression to get the data for the catalog entry, and once it is done we are going to move forward and display our data frame object. Okay, now we are going to simply run it to see what is the output. And once you execute it, in the output you will see three different tables. The first one is without any manipulation, which is the original data frame object. Then if you scroll down a little bit, you will see the updated columns but without having any catalog entry. This is the one that we did with the column object expression, but here you can see that our gender column has been updated and all the genders have been formatted as either male, female or unknown. And then if you scroll down, you will see that for the SQL expression, the catalog entry has been updated. It is showing us our function name for the UDF
and all different attributes, which means that a user defined function has been registered in the catalog. And this is all about using and creating user defined functions in Spark. In this video, I am going to talk about simple aggregations in Apache Spark, and for that I am going to create a new project, create a Spark session, load the data in the data frame, and then I am simply going to run different aggregations on the dataset. One thing to remember is that all aggregations in Spark are implemented via built-in functions. Let's start. I have created this project named aggregation demo having a data source invoices.csv. Let me open it. This data file contains a list of invoice line items. We have different columns named invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. Moreover, this dataset has repeating invoice numbers, which means that all these items belong to the same invoice. Let's come to our main file. Here I am creating a Spark session and then I am reading the data inside our data frame. Now we are ready to perform aggregation. Let's see an example. A simple aggregation involves summarizing the complete data and it is going to give you a single row in the result set. Let's see how. We will start with a data frame object and then I am going to use the select method and inside it apply the count star function. Then I will give an alias to the summary column. You can add another summary column for the sum of quantity like so. Here I am using the sum aggregate function. You can add as many summary columns as you want. Now let's compute the average price. We also have a count distinct function. It will count the unique values of invoice number. The select method will return you a new data frame and you can show it. Simply use the show method and then I am going to run it. In the output, you can see that we have summarized the whole data and got one single row in the result, and this is called simple aggregation. You can use these functions in the column object expressions just like we did, and also in the string or the SQL expressions. Let me show you how. I am going to use the select expression so I can pass a SQL like expression in it. This time I will use count1 which does the same thing as count star. However, counting a column field is different. Let me count the stock code. So count star and count1 will count all the rows even if they have null values, whereas counting a column field does not count the null values. Let's use the sum average functions too, and then I'm simply going to show it, and once it is done, let's run it. So we got the summary. The count 1 gave you the same value as the count star. However, the count field is one lesser because we have one record where the stock code is null. So this is the difference between counting all the columns or counting the column field. It also calculated the total quantity and the average price. So this is how you can use simple aggregations in Apache Spark. In this video, I am going to talk about simple aggregations in Apache Spark, and for that I am going to create a new project, create a Spark session, load the data in the data frame, and then I am simply going to run different aggregations on the dataset. One thing to remember is that all aggregations in Spark are implemented via built-in functions. In this video, we will convert our data frame to something like this using the grouping aggregations. Let's start. So I have created a new Python file in my project called grouping demo. I have created a Spark session and loaded the invoices.csv file into the data frame. Now I want to create the grouping aggregates as per the table shown here. Let's look at the requirements. We want to group the initial raw data frame by two columns, country and week number. We already have country field in the source data frame, however, we do not have the week number field. We can extract the week number from the invoice date. We have a built-in function called week of year which will give us the week number. However, the week of the year function expects a date field and invoice date is a string in our data. So the first task is to convert the invoice date to a proper date format. Let's do it. We will start with the invoice data frame and we will be using the with column transformation to convert the invoice date. Then all you need to do is to apply the toDate function to convert the invoice date into the specified format. That's all. Now the invoice date will be in a proper date time format. The sample data is a little big for computation, so I am only going to get the data for the year 2010. This is not a requirement, I am doing it to restrict the sample size. Now you can again use the with column function to add a new column for the week number. Extracting week number is simple, you simply have to use the week of the year built-in function. Great, now we are ready to group it. So let's use the group Y for country and then week number. We are now ready for aggregation. Aggregation can be done using the AGG method. Let's use it. For first aggregation, we will use the count distinct function on the invoice number. We will also give it an alias. So this is my expression for the first aggregation. Another way to do this is to store the aggregation expression in a Python variable and then use it in the AGG method. Let's use it. I am defining a variable and initializing it with the expression. Then I will use it in the AGG function here. Now let me define the second aggregation, which is the total quantity, and it is calculated using the sum function. So after creating the variable, I am going to use it inside my AGG function, and then I will simply define a third variable which is going to be the invoice value. So let's create it. For the invoice value, we are using the expression function in which we are calculating the sum of quantity and the unit price, and we are rounding off the result to two decimal values, and we are going to save it as a column name named invoice value. Now let's place it inside the AGG method. After that, I am simply going to save the result as a Parquet file, and here I am using the coalesce function. But you don't have to worry about it. This is for my personal use. And then finally, we are going to sort the data on the basis of country and the week number, and we are going to show the data. Let's run it to see the output. And in the output, you can see that we have generated the table just like I show you in the beginning of the video. So this is how you can use grouping aggregations on DataFrame. In this video, I am going to talk about simple aggregations in Apache Spark, and for that I am going to create a new project, create a Spark session, load the data in the data frame, and then I am simply going to run different aggregations on the dataset. One thing to remember is that all aggregations in Spark are implemented via built-in functions. We completed grouping aggregates and created the following data frame in the earlier video. However, I want to extend this example to meet the requirements to compute the running total week by week for each country. So the outcome should look like this. Here for week 48, the running total is the same as the invoice value, whereas for the week 49, it is equal to the sum of invoice value of week 48 and 49. Similarly, for week 50, it will be equal to the sum of week 48, 49 and 50, and it goes on in the same way for each country. And the same requirements repeat for the new country. This cannot be delivered using simple and grouping aggregations. So firstly, we will break this data frame by country, then we will sort it on the basis of week number, and finally we will calculate the running total using the sliding window. And all this can be done using the windowing aggregates. So let's start. I am using the same application app demo in which I have created a new Python file called windowing demo. Inside this file, I am creating a Spark session and I am using the logger object. After that, I am loading the Parquet data into the data frame. Now we are ready to aggregate the data frame and compute the running total. Let's define our window first. So I am going to create running total window, and you can set it using the window object. Here you have to define three things: partition, ordering, and the window start and end. Let's define the partition first. We want to partition it by country. Then I am going to order it by week number. And finally, we want to define the window. So we want to consider rows between the unbounded precedings and the current row. That's all. Now we have the window definition. And computing aggregate over this window is pretty straightforward. Let's do it. We start with the data frame and use the with column function to add a new column for the running total. And the value for the running total is the sum of invoices value over the running total window. Then we will simply show it. Okay, after using the show function, let me just run it to see the output. Upon running, you will see that we have successfully added a new column for the running total, and you can see that for the country Australia for the week 48, the first value of running total is the same as invoice value. For the second week, it is equal to the sum of the first two, and for the third week, it is equal to the sum of first three. So this is how you can use windowing aggregations in Spark on DataFrame. In this video, you will learn how to use inner join to join two data frames, and for that we will first create a new project in PyCharm. Then we are going to create a new Spark session. After that we will create two data frames from the list of products and list of orders, and after that we will use the inner join to join the two data frames by defining a suitable join expression. Joins are all about bringing together two data frames. Here is an example, and these two data frames are referred to as the left data frame and the right data frame. It is entirely up to you to decide which one you should take as left data frame and which one you should take as the right data frame. And we combine these two data frames using two things. First is the join condition or join expression, and the second one is the join type. Here is an example for the inner join. I am going to run this in a while, but before that I am going to make you understand a few things. I want to consider order df as my left data frame. So I started with the order df. We always start with the left data frame and then pass the right data frame as the first argument of the join method. The join method takes two more arguments, the join expression and the join type. The inner join is the default join, so you can leave the third argument if you want to use the inner join. So once you run this example, the Spark is going to take the first row from the left data frame and then compare its expression to all the rows in the right data frame to find a match. Then it goes to the second row of the left data frame and repeats the same procedure. And same goes for all the rows. The next step is to combine all the matching rows from the left and right data frame to create a new data frame. And this is where the join type comes into play. The default inner join will take only those records which are matched with at least one record on the other side. So in our case, all the rows got a match except for this row. The product ID 9 does not have a matching product in the right data frame. So we can expect all the other rows in the result set except for this one. Now let's implement this example and see the actual output. So I have created a new project called Spark Join Demo having a logger file and the log4j.properties file. This is my main file. Inside this file, firstly I am creating a Spark session, then I am initializing my logger. After that I am creating an order df from a list of sample records. We have already learned this. Similarly, I am also creating a product df which is created from a list of product samples. Now, let me show you the data frames. This is for the order df, and then I am going to show the product df too using the show function. And after doing that, I am simply going to run it. So here is my order df and here is my product df. This is the same example that I showed in the beginning of the video. Now we are all ready to join the two data frames. I have already discussed that in order to join two data frames, you need to define two things. First one is the join expression and the other one is the join type. So I'm going to start by defining my join expression, and the expression is going to be order df.product id is equal to product df.product id, and then we are simply going to use the join expression. Here I am using order df as my left data frame, and inside the join expression, firstly I am passing the right data frame which is the product data frame. Then I have passed my join expression and the type of the join is inner, and then I am simply going to show the data frame. Now let's move ahead and run this to see the output. So you can see that I got 8 rows as expected because the one row was not matched to any row in the right data frame. But I don't want all these columns in the output. So let me adjust it now. I only want to show limited number of columns. So I'm going to use a select function in which I'm going to display the order ID, product name, unit price, list price and quantity. This seems fine, right? But if I'll run it now, I'm going to get an error. Let me show you. Let's run it. See, I got an error. And the problem is quite obvious. This is because both my tables have a column named quantity. One is the quantity of the product in order and the other one is the threshold quantity. So because of the same name, it is giving us ambiguity. So when we asked for quantity, the Spark got confused and thrown us an error. We have two approaches to resolve this column name ambiguity. The first one is to rename the ambiguous column even before joining the two data frames. Let's try it. So I am going to define this new data frame here. Here I am using the with column rename function to rename the column quantity to reorder quantity, and the new data frame is going to be product rename data frame. So here instead of product data frame I am going to pass product rename data frame. Let's try running it now. You can see that now it works fine. The second approach is to drop the ambiguous column after performing the join. Let's try it too. If you carefully look at the data frames, you will notice that we still have another ambiguous column, which is the product ID, right? So if I select the product ID here, I'm still going to get the error. So we want to drop one of the product IDs after joining the two data frames. Let's do it. So I want to drop the product ID that comes from the product data frame. Let's run it now. Now you can see that the output is fine and runs without any errors. So this is how you can use the inner join on the Spark data frames.
In this video, you will learn how to use outer joins in the data frame, and for that we will first copy the code from our previous video. Then we are going to replace the join type to outer join and see the output, and then we will replace outer join with the left join and see the output.
We created the following data frames in the earlier video and we performed inner join on these two data frames and this was the outcome. I'm not sure if you noticed the missing record in the result. Order ID 4 has two products but we got only one in the final outcome. The record is missing. Why? Because we performed an inner join and the product ID 9 is not present inside the product data frame. Similarly, the standard keyboard does not show up in the output because none of the orders had a reference to the standard keyboard. This means the inner join will take only those records which are matched on both sides, everything else is left behind. So the inner join makes sense in only those requirements when you know that your data will match on both sides and you purposefully want to skip the missing records. However, in this example, skipping a missing record does not make much sense. We sold 3 units of something called product ID 9, but we do not know the name of the product. But we made a transaction, so we cannot lose it from the final result. But how to fix it? There comes an outer join. The outer join will pick up all the records even if they do not have a matching pair. Let's try it. I have created a new file called outer join and copied the code from the earlier video. Here is the code that we written in the previous video. Here I am going to change the join type from inner to outer join. And then here instead of these orders I am going to select all the orders. Let's enclose it in double quotes like so. And then I will sort the output by the order ID. Let's run it to see what we will get. In the output, we got 3 records for order ID 1. This was expected because we have a matching record on the right side. So these 4 columns are from the left side and these 3 columns are from the right side. Similarly, these 4 rows are in the output because we had a match on the right hand side. So up to here everything works like an inner join. However, we are also getting product ID 9. This item does not have a matching record on the right side, but it is still in the output because we used outer join, and since we do not have a match on the right side, so we do not know anything about these column values. And so these values are null. We got the record from the left side even if the right record is missing. Similarly, we also got the right record whose left record is missing for the first value in the result set. This means that the outer join will ensure that we get each record from both the sides at least once, even if there is no match on the other side. And this type of join is known as a full outer join because we take every record from the left and the right side both. But for our example, this record does not make any sense because we want to get sales record and not even a single unit of standard keyboard was sold. So this record does not make any sense here. To fix it, here comes a variation of the outer join. The Spark offers 3 types of outer joins: full outer join, left outer join, and right outer join. Full outer join will select all the records from both the sides even if we do not have a match. Left join will select all the record from the left side even if we do not have a matching record on the right side. Similarly, the right join will select all the records from the right side even if we do not have matching record on the left side. But in all 3 types of joins, the matching records will always appear. So to lose this record, we will use the left join here. And to do so, I am going to change the outer join to left join here. After that, I will go ahead and instead of all the columns, I am going to select these columns. Let's run it now to see the output. Now the output looks much better, having less number of null values. So this is how you can use outer join in Spark on data frames. Congratulations everyone, you have reached the end of our Spark Programming in Python for Beginners course. I hope you have enjoyed the journey and learned valuable skills that will empower you in your data processing endeavors. Before we wrap up, let's quickly recap what we have covered throughout this course. We started by understanding the fundamentals of Apache Spark and how it revolutionizes the big data processing. Then we saw the basic tutorials of how you can actually set up and configure the Apache Spark either in the DataBricks or in your local IDE. After that, we covered the Spark architecture and execution models in which we saw how you can create multi-node Spark cluster using GCP and also working with a Zeppelin notebook inside a cluster. Then we moved towards some advanced topics which were Spark programming models related to the data frame and the Spark session configuration, etc. After learning about the Spark programming model, we dive deep into the Spark data sources and sync, Spark data frames and dataset transformations, and we also saw aggregations in Apache Spark. And we concluded our course by seeing how you can perform joins in the Spark data frame. In conclusion, I want to express my gratitude for your dedication and enthusiasm throughout this course. Remember, learning is a continuous journey and Spark is a tool that can open doors to exciting opportunities in the world of big data. Thank you all for being part of this educational experience. Best of luck in all your future Spark adventures.